Now we're going to use regular polygons to find something very interesting about the exterior angles of not only regular polygons, but all polygons. So what I did here is I am telling you that a regular polygon has exterior angles E. Now I'm not really telling you how many sides there are. In this instance, I went ahead and threw up a pentagon so I could mark that exterior angle and you'd have a better idea of what we're talking about. So the first statement we're making is that each of the exterior angles measures E. That's given. So I said they're all going to be the same. So if I went ahead and drew other lines to show exterior angles, all these angles will be the same measure. All right? Now, and they also make a linear pair with the interior angle that's inside of the polygon. So I can say that when I add the two, they're 180, and that's the linear pair theorem. I can subtract E from both sides using the subtraction property of equality to get a value for A. A is going to be 180 minus E. I can also use the polygon angle sum theory to write the next equation that n times the number of angles is the total number of degrees inside of the polygon. Then, here's the interesting part. I'm going to take this A and substitute it in right there using substitution. So now instead of n times A, I have n times 180 minus E. Well, next step, the distribution property. So I'm going to go n times 180, n times E, 180 times n, 180 times 2. And that gives me this equation in step 6. Now I can subtract 180n from both sides of the equation, and technically I actually get negative ne equals negative 360. So that means that if I divide both sides, so that was the subtraction property of equality, then I use a division property of equality to divide both sides by n, and I get my formula. Any exterior angle of a regular polygon is just 360 divided by the number of sides. Another interesting thing you'll see is that the total degrees really for any polygon, when you add all the exterior angles, is just 360 degrees. So in this example, we're going to find the measure of an exterior angle of a 19 gon to the 10th degree. I'm going to write down my formula. The exterior angle is 360 divided by n. Substituting in 19 is 360 divided by 19. Get my calculator and I get about 18.9 degrees. The interesting part is I can also find the number of sides if I know the exterior angle. So I start with the same formula, but instead of substituting in for n on the right side, which is what you're used to doing, I'm substituting in for the angle E on the left side. Remember, we can use both sides of an equation. So 12 is 360 divided by n. Then I can cross multiply, and I'll get 12n equals 360. Divide both sides by 12, and I get n is 30. So for further reflection, how do we know that all the external angles of a polygon add to 360 no matter how many sides or angles? Well, we basically use the polygon angle sum theorem and the fact that the interior angle and the exterior angle have to add up to 180 degrees. When you work through the math, all the exterior angles have to add up to 360 degrees. How could you use the exterior angle formula to find the number of sides in a regular polygon if you only know the interior angle? You need to be able to substitute not just into the right side of a formula, but also the left side. And how did we use the properties of regular polygons to determine their exterior angles? I could show that same formula that all the angles add up to 360 for any polygon, but it's a bit more complicated. It's much easier to work with a regular polygon where we know all the interior angles are congruent and all of the exterior angles are congruent.